So in this problem we have x cubed is equal to 3x squared minus 7x plus 21. And our task is to solve for the possible solutions of x which make this equation true, or our roots. So first of all, our goal is to set the polynomial, the whole polynomial, equal to 0. So we want one side of this equation to be equal to 0. So this whole right side, the 3x squared minus 7x plus 21, I'm going to set that side equal to 0. So I'm going to subtract that whole polynomial from both sides. So we're left with 0 on that right side. So we're going to be left with x cubed minus 3x squared plus 7x minus 21 is equal to 0. And now we have the right hand side equal to 0. And now we're able to apply the rational roots theorem. So the rational roots theorem states that there are two numbers, p and q, and that when you divide p by q, you're going to get a number, and the factors of that number are possible roots of this polynomial. So in this case, our p is negative 21, and our q, when there's no coefficient in front of a x, it's automatically a 1. So our q is 1 and our p is negative 21. So we have our p divided by q is equal to negative 21 over 1, which is just negative 21. And we want to find the factors of negative 21. So let me list that. Factors of negative 21 are as follows: plus or minus 1, plus or minus 3, plus or minus 7, and plus or minus 21. So out of those 8 integers, some of them could be possible roots, and some of them aren't possible roots. So this is where the trial and error aspect comes in. We're going to need to test these roots one by one until we find a root that works perfectly. And what I mean by that is if you have a remainder that is not 0 when you do synthetic division, then it is not a root. But if your root gives you a remainder of 0, then it is a root. So let's start with positive 1. Let's try that. So I'm going to use synthetic division. So we have 1, and I'm going to take the coefficients from this polynomial. So the coefficients are 1, negative 3, 7, and negative 21. Set it up like that. So first step is to bring the 1 down. 1 times 1 is 1. Negative 3 plus 1 is negative 2. Negative 3 times 1, negative 2. This is 5. 5 times 1 is 5. So now we have negative 21 plus 5, and that's going to give us negative 16. But that remainder is not equal to 0. We have a non-zero remainder. So this means that 1 is not a 0. 1 is not a solution, or it's not a root of this polynomial. So now we have to try another factor of negative 21 to see if we get 0 as a remainder. So let's try 3. Let's see if this works. So bring the 1 down. 3 times 1 is 3. That's 0. 3 times 0 is 0. 7 plus 0 is 7. 3 times 7 is 21. Now we have negative 21 plus 21, and that's 0. And remember that it states that if you have 0 as a remainder, then this 3 is a root. So let me just list that down. So we have roots so far are 3. And keep in mind that this is a cubic function. We have x cubed as our leading term. So we will have 3 zeros, or 3 roots. So our next step, we can write this as factored. So we have x cubed minus 3x squared plus 7 minus 21. And what we did with the synthetic division, we essentially pulled out an x minus 3. That x minus 3 is the dividing. We divided by x minus 3 basically. And our quotient is this number down, these numbers down here, the 1, 0, and 7. And remember, this means 1x squared plus 0x plus 7. So we essentially pulled out an x minus 3, and we're left with x squared plus 7. So yeah, we found out our first root. Now we want to find out our remaining two roots by just looking at this part, the x squared plus 7. So we have x squared plus 7. Remember to find the solutions, because remember at the beginning we set the whole polynomial equal to 0. We're setting this equal to 0. So we have x squared plus 7 equals 0. We're going to isolate the x by subtracting 7 on both sides. We're going to have x squared is equal to negative 7. To get rid of that squared, square root both sides. We're going to have x is equal to plus or minus root of negative 7. And remember, when we take the square root of a negative number, this is where the complex numbers come into play. Right? Because we can see that this is x is equal to plus or minus negative 1 times 7. And remember that square root of negative 1 is I. So ultimately we're going to get x is equal to plus or minus root 7i. And keep in mind the plus or minus, that means we essentially have two solutions for x. We have the positive one and the negative one. So those are our final two roots. And again, since this is a cubic function, we would have at most 3 roots. So our roots are 3. 3, we have positive root 7i and negative root 7i. So those would be your 3 answers. Or if you want to write it like more like x equals, so we have x equals plus or minus 7, plus or minus root 7i, and x equals 3. So those would be your solutions. Like plugging these values into that original polynomial would be true. And if the problem asked for a factored form, you would write it like this. You would write it as x minus 3 times x minus root 7i times x plus root 7i. That's if the question asked you to write it in factored form, but your real solutions would be as I boxed above.